We're going to take a transformer, a mystery transformer, and see if we can figure out what this goes with or what we can use it for. It looks like a pretty hefty transformer, probably around a 50-watt transformer, probably for using 2 output tubes. Looks like an output transformer because it's got 3 wires coming out of this side and 4 wires coming out of this side. The 3 wires coming out of this side is probably the primary, and it's probably center tap because we see there's a red wire here, and usually red is the center tap, brown is one end, and blue is the other. But let's check this to see if that's the case. I'm going to connect the red meter lead to the blue lead of the transformer because I think that might be an end, and the black lead of the meter is going to the brown lead, and we look at that and see that that's about 80 ohms. Now, if the red lead is the center tap, I should be able to disconnect this from the end and put it to the center. It should read about half of that, which it does. We're getting about 40 ohms. So I would say that the red is the center tap, and the blue and the brown would be the ends. This has got to be the primary because the secondary of an output transformer is going to have ultra low DC resistance, probably less than an ohm. So let's assume that this is the primary, and let's take the other leads and see if we can figure out what these are for. There's 4, and we don't know what they are, but we'll start off by just putting one of the meter leads on one of the wires, and we're going to just check DCR, DC resistance, and go to all the other leads and get a reading. The ones that have the largest reading of the 4, and we can try it different ways, the largest reading is going to be the highest speaker impedance setting for the output. Let's see, we're going orange to green, we get a 0.67. Orange to yellow is a 0.52. Orange to black is a 0.91. We'll leave it on black. Change this to green. 0.40. And to yellow. 0.57. Leave that on the yellow. And try the green. 0.33. So the largest DC resistance was from the orange to black, which was the 0.9 or the 0.91. Let's see what it is. We'll try it again. Okay, 0.90. Now, we know that these are the ends of the secondary, the orange to black. Now, how do we know which one of these is going to be ground and which one's going to be the higher impedance setting? By the way, this one's probably going to be a 16, 8 ohm, 4 ohm transformer because since it's got the 4 leads, one's going to be ground and then you'll have 3 others. It's probably 16, 8, 4. It could possibly be 8, 4, 2. But we know that these 2 right here are going to be the largest of whatever it is. Now, on a transformer, when you go from 16 ohms to 8, or from 8 to 4, or from 4 to 2, you change the number of turns by the square root of 2. So this is also going to change the DC resistance by the square root of 2. So let's take the 0.9 and divide it by the square root of 2 to see what the next impedance setting would be. 0.9 divided by 1.414 equals 0.636 ohms. So let's see if we can find a 0.636 by moving one of these. We're just going to go ahead and leave the black one attached and assume that that's ground, and let's see if either of these give us our 0.63. We see that the green is 0.4. Next, I'll check the yellow, and we see we have a 0.57. So neither one of those were close to the 0.64. Let's go back and assume that the orange is ground, and we'll move the black to the green. And we get a 0.68. That's probably it. And then to the yellow, we got a 0.52. So now we know that the orange is ground, the black is the highest impedance setting, the green is the next one, and probably the yellow is the next one after that. Now if we take the 0.63 and divide that by the square root of 2, we see that the next one down should be about 0.45 in DC resistance. So let's see. Well, it's a 0.51. That's close enough. That's probably it. You're going to have orange as the ground. The black's going to be the highest impedance setting. The green's going to be half of that. And the yellow's going to be half of that. If this is a 16 ohm transformer, this would be 16, this would be 8, this would be 4. Now in order to double check it, let's check it with our variac, and we'll put some voltage on it and see what we get. We'll hook the variac up